Hello everyone, welcome to tutorial 2 for the NLP sentiment analysis project developed for the Dara Big Data Hackathons. So tutorial 2 is about using existing Python tools that can perform a very basic sentiment analysis. There's pros and cons to these kinds of tools. The pros being that they're existing tools, they don't take very long to run. You're not using machine learning, so you do not need or you don't require training data. However, they are also they have their limitations in terms of how sophisticated the amount of sophistication in terms of sentiment analysis that they can do. So these methods, the two that we're going to look at today, the toolkits are the text blob and Veda sentiment analysis tools. They both make use of what we call a lexicon, and in combination with various rules. So we say it's a lexicon and rule-based approach or method for sentiment analysis. So what is a lexicon? It's basically what you see in this table here, where each of these tools will have a dictionary or vocabulary of words that have been put together by the respective researchers who've developed these tools. And each word in the vocabulary has been pre-assigned a sentiment score. Positive words like beautiful and nice would have a higher, positive score, and words with a negative connotation or sentiment will have negative scores. And usually these words, in a text, then you will have these words being assigned their scores and then averaged somehow, or different rules that these tools use to then come up with an overall score for the whole sentence. And we'll go more into that for each of the tools. So there's a few drawbacks or limitations of these kinds of methods, and that is obviously that you will not pick up things like sarcasm or different tones, etc. In a sentence. Language, as we know, is very complicated, so this is obviously a more basic approach to sentiment analysis, and is therefore a bit limited, but it's still good to know that these things exist, and you can at least investigate the performance. It might be, in some cases, for some objectives of some research, it may be sufficient in order, it may be sufficient for the kind of sentiment analysis that you're trying to perform, or the kind of conclusions you're trying to draw, or insight you're trying to get. So so as I've mentioned, it may miss things like sarcasm, and also certain words that are often used in different ways. This may be missed as well. For example, this example I gave of, he killed many people. So here the word killed is negative, and is usually negative, has a negative connotation, but saying I killed it in that exam is actually meant to be, that sentence is a positive sentiment, but it may not pick up as such. All right, so let's first start by importing the libraries that are needed, basic libraries here, and then text blob and Veda. And we're also using Plotly for some cool interactive plots. I know most aren't used to using Plotly, myself included. Mostly use matplotlib and things, but there are a few cool features to Plotly that are quite easy to use, and in this tutorial we'll show a few how to create a few interactive plots that can be quite cool and quite useful. So import all of those, and we'll be working, for the purpose of this tutorial, we'll be working with data that we've already collected and labeled and cleaned. So this is data from Twitter around COVID-19. We loaded, it's about 4,200 or so entries of text about COVID-19 from Twitter. And they have the, this is label data, was manually assigned labels by people from the OED team who volunteered to help with this. So these will come in use later. We'll discuss that later. But first, for now, looking at the text blob sentiment analysis tool first. So text blob, it provides a polarity score and a subjectivity score for each piece of text. And I've explained here how the scoring works in terms of polarity. It's between -1 and 1, and the scores, having a negative or neutral or positive sentiment according to these obvious scoring. And subjectivity is given is a score between 0 and 1, and gives you an idea of whether the statement is more fact or opinion based. So a subjectivity of 1 will obviously be more opinion based. So it's also good to know a little bit about how the scoring or the rules work. So as mentioned, it's a lexicon-based method. So from a large library of words, people have assigned scores, polarity and subjectivity scores for each of these words. And then for any given text, text blob will look for all the words for which you can find scores, and then sort of average these to produce final scores for polarity and subjectivity. But in addition to that, there are a few rules that it will also apply to be a bit clever or a bit more sophisticated. So for example, if the word not appears in front of a word, so say the example of the word good has a polarity score normally of 0.7, but if the word not appears in front of the word good, then the rule is that the word good, the score, of the word good will be multiplied by -0.5, yielding an overall score of -0.35. Punctuation also has an effect on this. So for example, an exclamation mark will increase the polarity of a given text. Okay, so to make it a bit neater and easier, we put these into functions, and so we can easily just say, call the function, say get polarity, and put in your text here. So in cell number 4, the participants can just play around with this and put in any sort of text that they want, a text that they would expect to be negative, and a text they expect to be positive, and even play around with sarcasm or slang or abbreviations, and just see how text blob handles those and whether the polarity score seems to be accurate. So if I remove this exclamation mark, for example, you can see the polarity has dropped. So we know that exclamation marks have some sort of effect. So yes, just nice for participants to play around with this and get a feel for it. Okay, now we get the polarity and subjectivity score for each of the tweets in our data frame, and we've added these columns to our data frame DF. So we now have a subjectivity and a polarity score for each of the tweets. And then we're just going to give each of these a label, so negative, neutral, positive, by these rules here, just very intuitive, just to make it a bit easier for us to see at a glance. And we add this column to the data frame as well. So now we can just easily see what it's given to each, what label is given to each text. So now if we just want to quickly have a look at the distribution of negative, neutral, and positive tweets, all we do is we can, pandas has many cool functions. So if you just say dot value counts, you can get a very nice quick distribution of what you have. So we see here that according to TextBlog, they are mostly positive, the tweets. And I ask here to participants, is this what you would expect? And obviously, the answer is no. For tweets about COVID-19, we wouldn't expect a majority of them to be, a large amount of them to be positive. So let's look a bit further into, what's going on. So first we just order the tweets in terms of from most positive to in ascending. So the polarity in descending order. So most positive tweets at the top and to most negative tweets. So we're just going to order those like that by sorting it. Again, very easy to do with the data frames. And then we'll just print out the first 15. So this should be the most positive tweets. And they can just read through this and have a look and see, does this seem correct? Does it seem to be mostly positive or not? And in the same way, we can, well, here we looked at dot head, so the first 15, or we specified 15 is the first 15, and if we say dot tail, we can look at the last 15 here. So that should show us the 15 most negative tweets with most negative sentiment. So again, they can just see what they think about how well this is working. We'll now make use of Plotly to make an interactive plot. So first we need to just get into this notebook mode to allow for it to be interactive. And then I've got links here to Plotly and Plotly Express if they'd like to look more into plotting with these tools. Okay, so if we make this plot here of subjectivity versus polarity, and it's interactive. So if you hover over a certain tweet, you can have a look at what the text is and its assigned polarity and subjectivity, and just see, if it seems correct or not. Unfortunately, we couldn't find a way to wrap the text. So very long text, we can't really see the whole text. If any of you figure out a way to wrap the text, there's no easy way to do this. The only way would be to go and manipulate the actual text in the data frame, which we don't want to do that. But it's still cool to have an interactive plot where you can, very quickly check things out. And here we see, yes, it has given a mostly positive polarity to the tweets. And I ask here to the teams to just discuss what they can draw from this kind of plot, or what kind of information can they draw from this, and just have a quick chat with their team. Nothing that they have to present to us, but just for them to think about it. Okay, now we come to using the Veda sentiment analysis tool. So Veda is slightly more sophisticated than TextBlog in that, and it's also specifically tuned to social media text. So it's used to, slang and abbreviated language. It's meant to handle that quite well. As well as, things like acronyms that people commonly use in social media. So yes, just like TextBlog, it has a lexicon and rule-based method, but the rules used by Veda are slightly more sophisticated. So it looks at not only the polarity of the text, but also the intensity. So how positive or how negative a text is. So it looks at things like capitalization. So I suppose maybe in these cases you wouldn't want to, when if you were doing any pre-processing, you wouldn't want to convert all your text to lowercase, perhaps. Another rule it uses is but. When there's a but, it recognizes that as a shift in sentiment, and will the sentiment of the text will then be dominated by the score put together from the second half of the sentence. There's also booster words such as extremely, or add more intensity to the positive sentiment score. And it says that the Veda model also catches about 90% of cases where any negation flips the sentiment of the text. So that's quite sophisticated. Okay. Oh yes. So Veda, unlike TextBlob, which gives one polarity score and one subjectivity score, Veda sort of gives a score of each sort of. It has a component, a neutral, a negative, neutral, and positive score. So like a component for each text, and then also a compound score, which is sort of a normalized weighted composite of these three scores. So the compound score is a good indication of the overall assigned sentiment for that text. So that's what we'll look at. All right. So let's just make it simple and call it analyzer here. So we don't have to type out this long thing every time. And once again, they can just play around with it. And as I said, it gives a sort of different components of negative, neutral, and positive for your text, and then a compound calculated overall sentiment score. So it gives this quite a positive score, which is correct here, and participants can play around with this once again. So similarly, with as we did with TextBlob, we then get the Veda. We ask for just the compound score for each tweet, and add this to our data frame as Veda compound, and just to use the same method again, we'll get a label, so negative, neutral, or positive, and add this. So we've got now our TB, TextBlob sentiment, and our Veda sentiment. So already you can see some disparity here. But this is all, yes, been added to our data frame. And once again, we'll sort it and have a look at what it classifies as the 15 most positive and most negative tweets. So you can already see a very big difference here in the kinds of tweets that Veda has classified as most positive, in that these are much longer tweets, whereas the ones classified as most positive by TextBlob were very shorter texts. So it's good for participants to have a think about, why this might be the case, and obviously have a read through these tweets to see if they're really positive, and similarly looking at the 15 most negative, whether that seems correct. But again, you can see that these are long tweets. So it seems to handle or be able to classify long tweets more easily or more correctly. Okay. Now let's make another interactive plot to compare the scores between TextBlob and Veda. So yes, this is the sentiment that was assigned by TextBlob and Veda. So you can compare them. So polarity is that of TextBlob, and then the Veda compound score is the one from the Veda tool, and they can just have a look and see which is more accurate by just hovering them over, or just looking at the actual graph and what we can draw from this just by looking at it. We can see that immediately that text block has a few tweets that it's assigned as completely neutral along 0 here, and also there's a few that it's given, you know, at exactly 0.5, and I mean negative 0.5 and 0.5. You can see that. But yeah, there's obviously a lot of disparity between the two. Okay, so as an additional challenge, which participants do not, it's not compulsory at all, but those who are maybe keen to do so and are not behind schedule can definitely attempt it. And if they do attempt it, they can include it in their presentation at the end of the hackathon, on the last day of the hackathon, when they're presenting the work from their hackathon task. They can also then just present what they found in this additional challenge. And this helps for, you know, if we're struggling to decide for a winner and a team has sort of mostly or successfully or tried very hard to do one of these additional challenges, it could be in their favor, could benefit them, and could help them win. Okay, so we just asked them to do a little bit of, since the labels have been provided for each tweet, and we're just going to assume that these labels that were manually given manual classifications of sentiment by the OED team, we're just going to assume them to be correct. And we want to say, so if you take those labels as being the correct sentiment, what percentage of the tweets did TextBlog and Veda correctly predict the sentiment for, which performs better? And for each of the models for TextBlog and Veda, does the number of words or characters, because that's how they would end up counting them if they figure it out, does that affect the accuracy of the assigned sentiment? So once again, yes, not compulsory, but a nice little exercise for those who are keen to do it and who are not behind with time. Okay, so then again, just telling them here what they should be able to do after completing this tutorial. Not so important to understand too much about Plotly. And for the hackathon task, they will most likely not use these tools because we'll show them in tutorial 3 why you know, machine learning is more accurate and much more powerful for sentiment analysis. So this tutorial was just to introduce these existing tools specifically for sentiment analysis. If any of them would like to go on to do any basic sentiment analysis research or work, it's very nice to know that these things exist, as they are used even in industry for certain things, and people even use it as a baseline to when using NLP or using machine learning to do sentiment analysis. They will often use TextBlog or Veda scores as a basic baseline for sentiment. All right, thank you very much. I hope this was informative and useful to you. And next we'll go on to tutorial 3.